Welcome to this information technology presentation on low-code. So we're going to have a lot of cool subjects we want to discuss in terms of low-code, and they are digital transformation, IT governance, microservices, continuous software engineering, IoT, Internet of Things, AI, artificial intelligence. So let's get started with defining low-code. Low-code runs in the cloud as platform as a service. And we have also something else called no-code, which requires no coding at all, and that runs in the cloud as software as a service. So in low-code you just need to program like 5% of your code, and in no-code there's no coding at all. Because it runs in the cloud, you don't have to worry about storage, integration, and you also get big data analytics. So everything is handled by the low-code developing platform. The people developing in low-code are called citizens developers. They don't need to install an IDE, for example PyCharm or IntelliJ or Visual Studio Code. They just need to go to the website and they can start programming in low-code right away. There's no need for installation, no need for configuration, no need for a setup. Low-code is developed in something called low-code developing platform, and that is a GUI, a graphical user interface, where the user creates models. Low-code can actually use artificial intelligence, machine learning, and robotic process automation. Low-code gets its data from APIs. So, for example, you want to get your data from a customer registry. You will get it by hooking the low-code application up to the customer service registry. However, this may lead to security challenges. For example, do you know that the data you get from the customer database is correct? Or let's think of you getting data from an external vendor. How do you know it's correct? And how do you know it's not bad code? A definition of low code is development of apps with minimum coding. Articles and papers says that there are no widespread definition, but this is the best so far. So there are 4 approaches to low-code. The first one is that it's model-driven. So model-driven software development. So if I put up a pen here, I can draw something. So you have some input. For example, customers. And they go into some box, and this is a model, and we do something with the customers. So let's say that the customers are JSON coming in here, and we send them to maybe some other site as an output, and we do something with them. For example, check if there are new orders from that customer. So this is the product-driven development. The second approach is that it's rapid application development. This means that iteration goes fast. For example, when I develop in low-code, what I write is what I see right away. So there is no time delay between me developing and the result. The code is generated automatically. What I said was that 95% of the code is already written, so the user don't have to write it, but they can write like 5% the rest of the code. The programming is highly visual. You have in the low-code development platform, you have models on like the left side, or like that you can just draw in. You just place them, take them from the left side and put them into your sheet or where you develop. So let's think about digital transformation and low-code. Let's first think or define what digital transformation is. So it's about disruptive technology the usage of disruptive technology. And disruptive technology is something that alters the way we operate. So significantly alter the way consumers, businesses and industries operate. So we have 4 things that we want digital transformation to do, and so increase productivity for new business ideas, and also value. We want to increase the income. We want to increase integration by improving regulatory frameworks and technology standards. And we want to increase the social welfare in terms of culture. And when I say culture and social welfare, I think inside a company, the culture has to be innovative and collaborative. So we have to collaborate with the industry and within the industry as teams and not work in silos. We need educated people. We need new skills. We need communication. We need digital communication platforms so we can communicate. The data that we use have to be protected, so we need to think about GDPR, at least here in the EU. And the data has to be accessible, so we need to store it in the cloud so that we can easily get it and manipulate it. So the external barriers for using digital transformation in terms of low-code are that we are missing skilled labor force. So labor force, what we mean about this is that low-code is developed by citizen developers. So we don't need as skilled labor force as we have to do if we want to develop some applications using regular Python, for example. And the drivers are AI, machine learning, cloud and data analysis. So of course low code uses the cloud. We can use AI in the low code, AI as a service. We can use machine learning as a service. Low code is the cloud. It's platform as a service, or no code SaaS as a service, software as a service. And of course we can then do data analysis because we don't have to worry about storage. Today the IT department struggles because there are not enough people to meet all requirements. Hence low code is a good solution to keep up with the pace of digital transformation. One thing about low code is that it may not be as scalable, or it may be scalable. It depends on how we develop it. So for example, if we develop low codes as functions, small functions, then we can easily scale them up. If we build them like big application, then it's difficult to scale them up. The next thing I want to talk about is IT governance. And let's think about governance. Not IT governance, but governance. And what is it? It's like you have on the right side, you have the business. And you have some control mechanism here in the middle. Some control. And who has this control? It's the board. The board with its stakeholders, they do some control to the business. And the same goes for IT governance. You have the IT department. Here you have IT, and the IT has some control, and it's the board that controls IT. So IT doesn't control itself. IT is a department because they are going to be doing something good for the business. So IT governance, it's how the board directs and controls IT. The IT has to focus on business perspective, not IT perspective, because the control comes from the left, from the business. It does not come from the IT themselves. IEC 38500 explains and defines IT governance as says right here. So this is where I got my source from this. IT governance is a lot about IT strategies, and the board sets leadership, strategies and procedures for the business and IT. So hence everything is like the fusion between IT and IT governance. So before going to low code, the governance should be in place. The IT governance should say something about what we want to do with low code. Where do we want to have low code? Do we want to use Microsoft, or do we want to use Google for our low code source? So this is our important questions, because we have to think about GDPR, and we also have to think about security. For example, if the governance is set before people start writing low-code applications, then security is much easier. For example, we can say that all passwords has to be encrypted, or we only want to use, if we want to use Google, we only want to use Nord 1 as our server storage for low-code. Or we want to say that we want to use Postgres SQL instead of MySQL, or we want to use MySQL instead of Postgres SQL. So these are like things that we should think of before starting, and the reason should be that we want to set the control of the IT department, so the IT department don't figure it out themselves. And remember, when we think about IT governance and low code is developed not only in the IT, but it's developed everywhere in the economics department, and it can be developed in HR. So the governance has to go and control all of these. So they have to put up a strategy for low code before the people writing low code do it themselves. The systems has to fit together. So for example, if we have a customer database, we shouldn't create a new customer database in a low-code solution. We should instead use that database and put the system together by, for example, using API. And as I said, the power of low-code is citizens developers developing apps. So IT is struggling with developing enough apps. So the citizen developers have to create them themselves. And as I said, data security, very important. Where are we storing the data? How are we storing the data? Is it password protected? Do we have two-factor login? So these are really important, because we don't want a data breach. So luckily we used low-code development platforms, but they can get they may expose data for others. So governance is about setting the best practices for what we want to do. And we of course want to use reusability. So if one citizen developer writes a routine, other developers may want to use that routine. For example, if one citizen developer in HR writes a low code for onboarding new employees, of course a team manager wants to use that same routine. He doesn't have to create it, because the HR department has already created it. So I have to think about reusability, and of course sustainability. We have to think about how are we going to change the programs that we already created. And of course DevOps, continuously deployment. We don't want to end up in a situation where requirements change and we cannot follow up the new requirements. And of course low code should be upgradable. So if there is a change in some requirements, or For example, if you use an API for somewhere, but it's a new version, you have to think about how are we going to upgrade to the new version. So next is the IoT, and IoT is Internet of Things. For example, I have written here light bulbs. And of course, low-code can be used for IoT also, because there are low-code IoT platforms. So it reduces time to market, it decreases user engagement, and increase customer satisfaction and innovation, because we get faster deployments. We don't have to program everything in C, for example. We use low-code. And think of low-code. How do they do things? They use APIs. So you put a box, a model, just drag it in, and you connect it to some API. And you get data. You send some request, you get some data into your box, you do something, for example, do something here that turns on a light bulb. So this is how everything works. And if you press one other button, something else will happen. So it always uses API. So for example, there are like raining outside, send a warning, or something has happened, send a warning. Everything is API. And APIs are created. Next, microservices. What are microservices? Well, microservices are autonomously small applications that can run for themselves. They have a single responsibility. So one application, one responsibility. So, for example, a customer database, one microservice would be to get new customers and create them in the database. That would be one single responsibility. So it can be deployed, scaled, and tested individually, autonomously developed, and this is called a service-oriented architecture. And of course, low-code can you create microservices. It's how do you develop low-code that sets the borders. And of course, low-code is in the cloud as a platform as a service. No-code, SaaS, software as a service. So it takes advantage of the cloud. And all microservices are loosely connected. This means that they have some connection, but if one microservice goes down, the entire program does not go down. So this means that I can take one small piece of the application, take it out, and upgrade it, but my entire big application in a big window does not go down. So next, I think we're going to talk a bit about DevOps. And one question that arises is, can low-code fit into my organization because we use DevOps? Well, what is DevOps? It's the merge between development and operations. So it's a set of practices that combines software development and operations. And it's supposed to shorten the development lifecycle. So think about low-code. Does it shorten development lifecycle? Of course it does. And it provides continuous delivery. So if you edit an app in low-code, it will of course go right ahead, be delivered straight away. And it's a complementary to agile software development. I would say that I would say that DevOps is practices, culture change, and tools. And they have some key principles that we want to follow. They are shared ownership between dev and ops. They are workflow automation. And they are rapid feedback. And think about low-code, shared ownership with dev and ops, of course. when the developer writes a code, she will see that it's put into production right away. But she is the owner of the code, so there is no ops. She has the complete ownerships. Workflow automation is using like scripts to automatically deploy application, and low code is automatically deployed. And of course she will get feedback right away that the code is deployed. So a problem here arises with the ownership between dev and ops, because the IT, if one girl from economics creates an app using low code and you have IT over on the other side, IT, there's like a border here, and this will be IT, but you have IT on this side also. So this is what we call shadow IT. So there is all IT, but there's a shadow IT. So you're missing maybe the link between development and operations. The citizen developer are responsible for both. So think about the development operation circle. It goes from planning an application to coding it, to building it, to testing it, to releasing it, deploying it, operating and monitoring it. So the citizen developer are actually responsible for the entire phase, the entire DevOps phases. She is responsible for all the phases in the DevOps model. Let's have a look at continuous software engineering and low code. So continuous software engineering is almost the same as DevOps, but DevOps is more like a marketing term, and continuous software engineering is the central part of DevOps. So it's about establishing a strong connection between all of the software engineering phases or activities. So continuous software engineering is to establish a strong connection between software engineering activities. And the reason why we do it is to increase the software process. So accelerate and increase the software process. So DevOps uses tools. So continuous software engineering uses tools. So we have automation, we have code collaboration, so we can work together on the same code. We have verification, we have version control, deployment and release. And we have different or several continuous activities. So activities that goes on and don't stop. It's integration, it's delivery and deployment. As I said, DevOps is a commercial term. Continuous software engineering is what we do. The last part of this presentation is low code and AI. And what is AI? Is mimicking human mental facilities on a computer. And it's very difficult to test because you train a model and you use it. But how can you test it? You don't know. You have to just see if it gives some correct answers or not. So the quality of the software is difficult to check and to create, because it requires a skilled force. The data management for low code is difficult. At least we have cloud computing, so we can store a lot of data in databases, and the deployment of models is difficult. Of course, project management is also difficult. The project manager needs to know a lot about AI. We need to have infrastructure in order to use AI, and here the cloud comes into use, because it has almost unlimited storage. And when it comes to requirements engineering, we have to think about the goal. It's goal oriented. We cannot set requirements that this software should do this and this. We have to think of what is the goal of the software. We have to think about GDPR, the right to be forgotten. So if you train a model with some data and a user says that she wants to be forgotten, how can you ensure that she is not part of that model? And also security is difficult. The AI are trained not to see problems. So if someone uses that for their advantage, the model then will not see that there are any problems with the data coming in. So let's look at the machine learning workflow. First, you need requirements for the model. Next, you need to collect data. Then you need to clean the data. So think of data collection as an alarm from a defender alarm. And there's a lot of data, and you have to do something with it. You have to remove the parts that you are not interested in. Then you can label each data. For example, put it in the Postgres database with columns, so you know what the different data are. Then you can start and train your model. And as you go training the model, you may have to go back to the labeling part. You may have to undo something, change something. Then you evaluate the model. How is it working? And if you are happy, then you can deploy it. And then, of course, when it's deployed, you have to monitor it.